Okay, thank you for coming. Let's get started. I'm Shohei Hido from Preferred Infrastructure, Japan. And today I will talk about Jubatus, real-time and highly scalable machine learning platform. And Jubatus is an open source software for real-time deeper analytics by distributed and online machine learning. And I'm sorry, this slide is older version, right? Yeah. So, okay, so I will proceed. So maybe someone get help with us, but actually this is joint work with NTT Lab in Japan, and project started almost 2 years ago, and we released this initial version in October 2011, and you can download it from GitHub today. And Jubatus is a combination of distributed machine learning and online machine learning for scale-out high throughput for model training and prediction, and memory efficient, low latency, and adaptive model updates. And the bottom line of this talk is very simple, just 2 words. Please try Jubatus. Actually, how many people are interested in real-time application of machine learning? Okay, so how many people know Jubatus before this session? Yeah, okay, this is the truth, so that's the reason why I'm here. So I will try to motivate you to use Jubatus on your business application or your system in the following slide. And let me introduce our company briefly, because no one knows our company. We are a very small software company in Tokyo. We have only 36 employees. And these 4 areas are our expertise, and we have 3 products. And today I will talk about Jubatus. And this is agenda of my talk, and I will talk about what is Jubatus, its motivation and application. And next I would like to explain how it works, and finally I would like to show how to use it. Okay, I was there in last year's Hadoop Summit, and I was very surprised that almost everyone talked about real-time something, like real-time processing, real-time analytics, or the definition of real-time or real-time business intelligence. And actually, we have some real-time software in the last 1 year, like Impala or something like that. So real-time big data analytics is a trend so far. And this is simple view of the big data analytics, and there are 2 axes, the decision speed and decision depth. And actually, Hadoop applications go both directions very fast. But in our view, there is still a white space in the both faster and deeper analytics area in the point circled. So our vision is that big data analytics will go real time and deeper in the future. So we focus on the second concept and third concept more in real time and deeper analytics for Jubatus. There are possible applications like Twitter analysis for personalization, or anomaly detection from M2M data, or energy management, or security monitoring, something like that. And actually, Jubatus is being used in Twitter reselling service in Japan. And Jubatus can classify over 5,000 tweets per second on only a few servers. This is joint work with entity data also. But actually, Twitter is just beginning of Jubatus application because the amount of data is not so large compared to other M2M applications like healthcare or network monitoring or car traffic sensors or video streams from surveillance cameras. For that purpose, we got Japanese government fund for improving the scalability of Jubatus now. So in the future, we will try to apply Jubatus in this area. Okay, so next, I would like to talk about the architecture. And actually, Jubatus supports almost all machine learning tasks except clustering so far, like classification, regression, nearest neighbor, recommendation, anomaly detection, and some graph analysis, and simple statistics. So you can use it for your application based on distributed environment. But actually, it is not so easy to make machine learning algorithms work online and distributed because almost all machine learning algorithms assume that the process will be done in a batch processing manner. So the process is very different. For example, we have 3 servers here, and each server train each local model by themselves, and sometimes they will have communication for synchronization, and after that, they iterate their local model updates. But online learning requires frequent model updates, but naive data distribution between the servers lead to too many synchronization operations, and so it causes performance problems in terms of the network intensity or the model accuracy. So our approach is to make the model loosely shared between the servers. Actually, Jubatus only shares the local models in a loose manner because the model size is much smaller than the size of data for synchronization. So Jubatus never share data set between the servers, and this is very unique approach compared to other framework for distributed machine learning. And for that purpose, we define 3-phase operations: update, mix, and analyze. Based on these operations, algorithms can be implemented independently from distribution logic or data sharing logic or failover logic. And these are the 3 operations. And update operation correspond to the training of machine learning model. And we got sample and send it to one server and learn and update the model on each server. And right-hand side, we also have analyze operation, and analyze correspond to the prediction using learned model to each sample. We got each sample and send it to one server and get prediction result from the server. And the point is that these operations are completely local, so you can improve the scalability just by adding more servers. There is almost a linear scale up with the number of servers for using Jubatus. And the key is the mix operation. This is a global operation in the back end, and the mix operation will try to correct models from the servers and merge it into one unified model and distribute the model back to all of the servers. Okay, so update and mix and analyze is the key concept of Jubatus. And this is a sequence diagram for mix operations. And in this case, we use linear mix operations, one to rest communication. In the beginning of mix operation, here we have 4 servers, and we randomly choose the parent of the mix operation. This time, the server A is the parent, and it gets log from the zookeeper, and it will communicate with all of the other servers to collect their model diffs. And after that, the server A mix the model and send back the unified model to each of the other servers, and log will be released. This is very simple diagram for mix operations. And based on these operations, we can implement many kinds of machine learning algorithms. Here is very simple example for distributed average computation. This is just a toy example, but many machine learning algorithms can be done in a similar way. Here we have very simple model with the number of sum and the number of coming samples. For example, we have new sample 5 and randomly chose one server and update the model with the number using the update operation. And here comes another example, 7, and another model will be updated based on the sample. And after that, we will have different local models on each server. And in this time, the analyze operation will result in different outcome based on the choice of the servers. However, we can make mix operation in some time. In this case, the rightmost server is the parent of mix operation. We just add the sums and numbers, and the models will be sent back to the server 1 and server 2. And here we have the same average result from all of the servers. And in this way, we can trade off between the model consistency and scalability by using Jubatus's update, mix, and analyze scheme. And here there are 2 types of models in Jubatus. One is linear model, like for classification and regression. Each server has its local model with a vector of weights, W1, W2, and W3. And in the mix, we just take average of the weights collected between the servers and make it unified model. And another model format is nearest neighbor based, and we have hash values in each server corresponding to each original samples, and these hash values can be used for approximate distance computation. So only bit arrays are shared between the servers, like based on the mix operations. We can execute any kind of nearest neighbor query based on the mixed model on each server. And this is software architecture of Jubatus, and it uses standard client-server system. And we have Jubatus client and Jubatus keeper on the client machine side, and zookeeper and remote procedure call handles the connection between the client and servers. So user do not need to care about the connections. And we have clients for many languages, C++, Java, Ruby, and Python. So you can plug it into your system. And on the Jubatus server side, we have two internal components named FV converter and algorithms. FV converter corresponds to the processing of data, like summarization or natural language processing or something like that. And after that, we will have a set of feature vectors. And algorithms can process the feature vectors as ordinary machine learning algorithms and get the model as a result. Okay, so I would like to talk about how it works. And first, I would like you to visit our website. Sorry, I'm missing the screenshot in this slide, but we have Jubatus website named jubat.us, Jubatus. Just put it on your browser. And we have overviews and API documents and tutorials and other references from there. And next step, because installation of new software is always annoying, so we provide VM images packed with Jubatus. So you can try it from, download it from our server. And the tutorial includes how to run the server and how to use the client and how to use some simple examples and how to configure the Jubatus servers. And we have VMs for virtual machine and VMware, so you can try it on any OS on your side. And after that, if you are familiar with Jubatus, you can download it from GitHub, as you always do. And please play with Jubatus example. We have another repository for Jubatus example, and we have many toy examples for many machine learning tasks, classification, recommendation, regulation, and graph analysis with many languages. By looking into that, you can learn how to use Jubatus from many languages. And in terms of the relation between Jubatus and Hadoop, we have HDFS connector to Jubatus. So Jubatus can communicate with HDFS for loading data from HDFS and put the result back to HDFS. This is not open source software, but we can provide it to you if you want. And here is evaluation performance on older version of Jubatus, and we compare the QPH performance by changing the server processes or client processes. And the result is that Jubatus achieves more than 3,000 QPS for updating classification model, and for analyzing, we get 6,500 QPS on only one server for classification. And actually, classification scales linearly with the number of server processes and threads. On the other hand, in the bottom line, the recommendation performance highly depends on the ever-coming samples, because recommendation is based on nearest neighbor, so nearest neighbor does not scale well to the number of the samples. But the QPS is still impressive, I think. Okay, so the summary part. And Jubatus is the first in open source software for online distributed machine learning on big data stream. And you can download it from GitHub, and we welcome your contribution and collaboration. And here is one more thing to help you to use Jubatus. And actually, our company opened a subsidiary in San Jose this April, right a few miles away from here, next to San Jose Airport. And we begin doing business in the US. So we are happy to have discussion with you for your business problems or your interest in Jubatus in the future or after this session. Okay, so I'm sorry, I have another content in my New Year slide, but something goes wrong, so I have nothing here. And so I would like to talk about the additional parts. And yeah, in terms of the relationship between Jubatus and Hadoop, you can use Jubatus as a metadata generator. I mean, if you have real-time stream input, you can input the data into Jubatus, and Jubatus can add some additional columns like predefining the categories or outlier scores or clustering result or expected values, something like that. And with these additional columns, you can make some aggregation or analysis on your data store, as you always do, like with more rich analytics access, right? For that purpose, Jubatus is very useful because once you store a petabyte of data, it is very difficult to make prediction model based on it, right? Because the size does not fit to main memory, so you cannot use R for learning from the big data. So, but Jubatus can process one sample by one sample, so you can build model if you use the correct, appropriate architecture in between HDFS or RDB or NoSQL DB or search engine to Jubatus, right? And another slide said that in our future view, it will be impossible to store all data into one place if you have more and more data, like video streams from millions of smartphones or car cameras or something like that. It is not efficient to collect all of the data into one place, like cloud or Hadoop cluster. We call it edge-heavy data architecture. We mean in such applications, we have to do some intelligent operations on the edge side, not the cloud side. I mean, if you have video stream on your smartphone, you have to analyze and make some result from the streams on your smartphones. And smartphones or car sensor cameras can communicate each other to make some more intelligent decisions or actions for the users. I think that will be key component in the future architecture of big data analytics. We have some possible customers talking about such kind of applications, and if you are interested in such kind of application, please talk to us in the future. And so that's all. Thank you for attention. Any question?
Your Twitter example,
Yes.
in terms of the categorizations, you mentioned you're doing real-time categorizations. Can you expand on it a little bit? You know, what kind of categorizations were done? How were those categorizations consumed, you know, utilized? And give me some use case examples if you have them.
Oh, you mean how can we use the Twitter categorization, right?
More specifically, what happened with the Twitter, you know, categorizations? What did you use for them? What happened to them?
Actually, a lot of marketing people are very interested in the tweets related to their company's products or reputations, because it can be used for customer feedback, implicit feedback coming from Twitter.
Well, it's just a question, you know, were you looking for, you know, people propensities? Were you looking for tendencies? Were you using those tendencies then to make marketing decisions? Were you looking for product tendencies? You know, cross-sell, upsell, you know, those kind of things. I was kind of curious as just a little bit what, you know, I'm getting real-time information, I'm capturing real-time behavior. I want to drive something. So I was kind of curious what was being driven and what were you trying to get to? So just want to get some expansion on that.
Okay, thank you. Okay.
So you mentioned that actually there is an HDFS connector available, right?
Yeah.
But it's not open sourced.
Yes, so far we have.
Is there any plan to open source it? Is there any plan to provide it as an open source software, or like we have to work with you to get the software?
Actually, we just built it, so we did not decide how to distribute the connector as an open source software or proprietary plugin to Jubatus.
Oh, I see.
Yeah.
Thank you.
Hi.
Hi.
Can you talk about some of the sources of data? For example, if it is a Storm application, you have various spouts for. So do you have? So what is involved to provide different sources of data to?
You mean what is the difference between Jubatus and Storm? Right?
Sort of, yeah, and yes, and also I was more interested in providing different kinds of streams. Something could be coming from Kafka, or something could be from like Twitter API. Is there an API in Jubatus to provide different types of inputs?
Yeah, actually, Jubatus can be used for such kind of processing, but the difference is that you cannot communicate. In the Twitter Storm stream, you cannot communicate between the streams, right? So that's the problem for building efficient machine learning algorithms based on the distributed processing, right? Yeah.
Right. Yeah, that's more on the processing. That's more on the processing side. I was asking even more basic, just like say I want to provide. I'm running your tutorial, an example, and then I want to provide a different type of source. Say, like what is like? How do you consume Twitter right now?
Many kind of data sources, how to build prediction model based on Jubatus, right?
Right, or you can talk about the already supported data sources. Like how do you consume Twitter Firehose right now?
I think it depends on the client side of Jubatus. So Jubatus is Jubatus server is the machine learning machine, but the client can be embedded into any kind of software. So if you have output plugin to your system, you can make some pre-processing or data aggregation on your side. Yeah.
Okay. And one last question. So does each server node store its own local state persistently, like if it needs to restart or gets restarted?
You mean how to manage the local models?
Right, if local mode, one of those servers restarts.
Oh, yeah. Actually, we have models in memory only. So you can save the model into local file system, and say I'm sorry. You can save the model into file system, and you can load the model back to the memory from the file system. But there is no sophisticated model configuration. So if you have run the model on another server, you cannot reuse the model on other server, right? Yeah. Okay, no more questions? Okay, thank you for coming.